Hi, everyone. Thank you for joining to today's presentation. I'm Gjoko Kostadinov, and today I'm going to be presenting about how big data and machine learning changed the world. Before, a few words about myself. I have been software developer for more than 7 years, and I'm in Scalefocus for 3+ years. So at the moment, I'm technology team lead for the data team, and I'm gonna share some of my knowledge that I've acquired through books and through projects. So starting from the beginning, we cannot talk about machine learning and big data without talking about the origin of the two. The origin of the machine learning starts with Arthur Samuel at IBM, who was a pioneer in artificial intelligence and computer gaming. He coined the term machine learning in 1952. It's worth here mentioning that machine learning is actually a subdivision of artificial intelligence. Machine learning focuses on the part where machines are able to learn through past experiences and past information. What Arthur Samuel did at IBM is that he created a program that was used for playing checkers. You all know the game checkers. The game actually was able to play better through learning more from its previous experience. The program itself used a min-max algorithm for studying the winning strategies. From here on, from 1952, we can discuss in detail regarding some of the more important discoveries for machine learning. The first one is for Donald Hebb, who published The Organization of Behavior, and he introduced the theories on the interaction between neurons, which later became crucial part in development of machine learning and neural networks, which are today used by Google and other tech giants. In 1950, Alan Turing, we'll remember him from deciphering the Enigma code. He invented the Turing test, or the imitation game, which was a test to determine if a computer can pass for a human based on its written linguistic fluency. Moving on, in 1951, Dean Edmonds and Marvin Minsky built the SNARK machine, the first machine with artificial intelligence neural network based on Hebb's model. In 1952, a year later, Arthur Samuel actually developed a computer game of checkers, which was used to test a lot of machine learning algorithms and methods. In 1967, Thomas Cover and Peter E. Hart came up with the nearest neighbor algorithm, which we all know for K nearest neighbor. This algorithm is used in a lot of today's recommendation engines that are used by big companies like Amazon and Facebook to propose us and offer us similar products or products similarly bought with other items. Also, this algorithm, nearest neighbor algorithm, later became the foundation for pattern recognition. In 1997, IBM supercomputer beat Garry Kasparov in chess. This marks the first time in human history where a computer program based on machine learning was able to surpass human knowledge, because I don't know if you all know, Garry Kasparov at that time was a chess grandmaster, and you could safely say that he was one of the best chess players at that time, and the machine was able to surpass him. Moving to a more recent history, in 2006, Geoffrey Hinton invented the fast learning algorithm, which was based on an RBM, and came up with the term deep learning to explain how artificial intelligence based on machine learning can learn like human. Now, what does deep learning mean? For those of you who who are not familiar with the term, deep learning refers to the part of machine learning where the program itself is presented with the raw data, and the program itself actually decides which of the data inputs and parameters are important for building the model. In 2011, IBM's Watson beat a human on Jeopardy, thanks to machine learning algorithms for classifying and deciding on which answer is the best, and also thanks to NLP, which stands for Natural Language Processing. The program itself used NLP in order to parse and process the data and to extract the knowledge from the sentences themselves. A year later, in 2012, Google developed Google Brain, which is a machine learning algorithm for recognizing cats in images and videos. It marked a breakthrough in image processing, which was later on, 2 years later, caught by Facebook and used to create DeepFace, a facial recognition system capable of detecting faces in images, accurately identifying humans. Facebook, now known as Meta, is the platform that we all use, which contains the products like Facebook and Instagram. And we are all familiar that there we have features that actually give you the ability to tag the other people that are in the photo with you. It uses machine learning for one part to detect where are the faces on the image itself, and for the second part, in order to classify the faces themselves against your network of people, in order to see if those people are your friends and to suggest that you tag them there. This is actually used to increase productivity into the tagging system and to increase tagging efficiency. At the same year, Google also introduced Sibyl, which is a machine learning system for predicting user behavior, which is designed primarily for better advertising. We all know that Google Ads is one of the best ad system in the entire world, and this is thanks to machine learning that actually is used to help classify millions of different types of ads and actually show them to the appropriate users and to the appropriate demographic strata. In the same year itself, chatbot Eugene Guzman passed the Turing test, although it convinced only 33 of the competition judges that it was human. This is also very important because it marks a new dawn for human in computer-to-human communication, which basically means that a lot of customer-speaking, customer-serving jobs will be filled by bots in the future. In 2016, Google's AI-powered AlphaGo beat a professional player in Go, an abstract strategy board game. This is the second milestone in human history in which actually a computer program surpassed the system. Because, as some of you know, the two most strategy learning and inducing games are chess and Go. Computers managed to beat us in both, as demonstrated in the slides here. And also, we could say that later on, AlphaGo version 2 actually managed to learn from the games it played with itself, and it created entirely new strategies and entirely new mechanisms to play against person, strategies which were actually not seen in the previously played human-to-human or human-to-computer games. Now, this is basically the origin of machine learning. Now we need to talk about the origin of big data, but we cannot talk about the origin of big data without mentioning Maury and Maury's charts. Now, who was Maury? Maury was a Navy captain in the US Navy. Due to personal accident, he managed to break a hip, which was badly reconstructed, which needed to be rebroken. And even after that, he was left with partial invalidity in one of the legs. and because of that, after 3 years of healing and recuperation, he was put in the depot of charts and instruments. This was a desk job that was part of the US Navy, and there, while dusting the room, in the back of the room, he found the old logs and entry books. And while for most of the other captains, these books were considered to be boring gibberish data with the occasional limerick and joke that was written on the margin of the books. And basically these books were just used to pass the time while being on long and uneventful journeys and voyages over the ocean. For him, these old logs and entry books presented a gold mine. Why? Because in these books, he found the potential to fix the charting system for the US Navy Marines and tune the charts themselves. First, he started with the system itself, and he created the initial guide for navigation through the waters. And he used that guide to test his validity and his theories. In most of the voyages, he managed to actually cut the voyage time to by one third, which means that he managed to reduce the traveling costs by 1/3 for the merchants, which was actually a great improvement in the US economy, in the US naval commerce. After that, he was promoted to Commodore, and we can basically just say that Maury took the material that seemed to have little use and extracted information from that material and turned it into eminently useful data. This is a prime and one of the first examples for data mining and big data. Doing so allowed the information to be used in a novel way and to create a unique value from already existing data and find its second repurposing. One of the captains actually quoted for Maury that until, I quote, "until I took up your work, I have been traversing the ocean blindfoldly," which just shows that even in that time, how much of Maury's work was appreciated and revered among other sea captains. Going on, these are another 3 examples of the history of big data, where human first interacted with big data. In 1663, John Gaunt dealt with overwhelming amounts of information while he studied the bubonic plague, which was at the time haunting Europe and had decimated Europe's population by 1/3. We can say that Gaunt was the first ever person to use statistical data analysis in order to predict the losses and the spread of the bubonic plague. In another very important example from history is in 1880, when the US had to do a census, and the US Census Bureau announced that they estimated it would take 8 years to handle and process the data that was collected during the census program that year. That means that after collecting the data in 1880, they would need to process the data until 1888, which would actually render the data invaluable and obsolete. But luck turned when in 1881, a man from the Bureau, which was named Herman Hollerith, invented Hollerith tabulating machine that reduced the calculation work. With its help, Herman Hollerith actually managed to reduce the processing time from 8 years to less than 1 year. Another example is in 1965, when the US government built the first ever data center, which was part of the IRS, with the intention of storing millions of fingerprint sets and tax returns, which actually in practice is the first data center ever built in the world. Now, let's talk about the classification of the usages of machine learning and big data. As we can see, there are 4 main categorizations of the usage of machine learning and big data. The first one is anticipating and capitalizing on emerging industry and market trends. Basically, an example of this is the music industry, where the music studios use a set of parameters to predict if a song would be a trend or not, and that way they can invest their money more smartly and make better educated guesses. I would say that another example for this is the trading markets, where trading bots use advanced algorithms based on machine learning and other formulas to create, to make new trading offers. And this actually optimizes the work to the market and has digitalized and automated another profession. The second one is analyzing consumer behavior and automating customer segmentation. Basically, we are the users, we're the products of this, because each one of us has some kind of social network where we have created a profile and where we have liked and disliked pages and videos. And based on this data, we are classified first in gender category, then in location category. After that, we're classified in demographic category and age category. And based on our likes, dislikes, we're put in certain neighborhood where when we go online, similar ads are presented to us that have been watched by people similar to us in our demographic group, or by people who have similar likes and interests. The third group is personalizing and optimizing the performance of digital marketing campaigns. And this is example of this is using user data to create smarter and more personalized thoughts in order to make sure that we are the user actually seeing what they think that he might like to see. Basically, this is predicting our behavior and our taste in music, in our political ideology. Here we can mention the infamous example of Cambridge Analytica, where it used a lot of Facebook-based data to create ads and target separate demographic groups in order to win and to rig elections. The last one, the fourth, is using intelligent decision support systems fueled by big data, AI, and predictive analytics. Actually, this one is used by big companies to predict data and to predict outcomes for big decisions. Basically, this is used in decision support systems, that's how they are called, by middle or top management, in order to make sure that the educated guesses and the decisions that the companies and the CEOs make are supported by data and can actually predict the outcome to some extent. Moving on, we cannot talk about data without mentioning Pat Helland's famous quote: "If you have too much data, then good enough is good enough." Basically, what this means is that Basically, what this means is that when we are talking about big data, we can never be 100% accurate, and we should leave that 20th century paradigm behind us. We need to make sure that our algorithm and our predictions are at most best as the algorithms and predictions of a human level professional expert. And if we get to that level, that means that our algorithm is one of the best and actually serves its purpose. There are a few rare cases that I mentioned where there is the AlphaGo program and the chess program that beat Garry Kasparov, but those are examples where actually where computer programs surpass human experts. Also, another paradigm that is worth mentioning here is that we need to leave behind us the paradigm that when working with big data, we need to know the causality. We do not. What does this mean? That, for example, we don't, in order for our algorithm to be successful, in order for us to reap the benefits of the data, we need to know the correlation. That means we need to know based on which trend what might happen, but we don't need to know why that would happen. Basically, what we need to get used to is to work with big data algorithms in more of a black box environment, where we see the data, see the correlation, and actually don't waste time with solving why this happens. Now I'd like to present a few examples of how big data and machine learning actually help make the world a better place. First one is the 2009 Google census problem. In 2009, as we all know, a new strand of a flu emerged, which was the H1N1 flu. It was a combination of swine and bird flu, and it was spreading very rapidly. Now with this flu, when this flu hit America, the problem was that the old way of processing the infection protocol was that the CDC processed the data by the doctors, which actually took 1 week to process, and then it posted that data for nationwide use. The problem with this is the first one. First is that people don't go to the doctor immediately after they're infected. They go to the doctor after 1 week of being ill. And the second one is that having one additional week means that from infection until going into the statistics, for one person, it took approximately 2 weeks. And for fast spreading flu like H1N1, 2 weeks was a very long time. It was almost like infinity. So here Google stepped to the plate. Google took 50 million of the most common search terms that American type and compared that with the list of the CDC data on the spread of seasonal flu between 2003 and 2008. In order to create a model, Google processed and tried 45 million different mathematical models and found that 45 search terms that correlate between their prediction and the national numbers. With this, and having in mind that actually this prediction system works ahead of time, Google managed to reduce the time of processing and predicting how the virus would spread from 2 weeks to less than a few seconds. Another example that some of you might know, but still it's worth mentioning when talking about machine learning and big data, is the example of 1997 Amazon and the recommender system of Greg Linden. At that time, Bezos employed Linden, and he was the engineer that was in charge of working on the recommendation system. Just to give a context, at that time there was no recommendation program, but the recommendation itself was done by a team of editorials. Now, from reading from that time, people were having the feeling that actually using Amazon at that time was like being walked around by the village idiot, because you got recommendations, but you got very few recommendations, and a lot of those recommendations actually kept on repeating. Why was the reason for this? The reason for this was that actually while the people that did the recommendation themselves were experts, they were not able to see all the differences in flavors and in book tastes, and could not make the relations themselves. Greg Linden was the engineer that actually had the idea to create a system that will use the previous data of Amazon, of the previously bought books, and create the item-to-item collaborative filtering. This item-to-item collaborative filtering was in charge of and was actually the one that made Amazon ahead of its competition. It was actually so good that it swept around the people who thought that there are bookshops or other kinds of shops that actually sell merchandise for some of the most eccentric users. it made them obsolete as well, because the collaborative filtering was very effective. At the end of the month, when they presented the examples themselves, they saw that the increase of the results of the increase of the books bought by the collaborative filtering against the results of the books bought by the editor's recommendation was very different. Actually, there is one quote in Greg's memoirs where he says he remembers that each time one of the editorials got his resignation letter, the number of books bought jumped a bit, because one more portion was taken by the recommendation system. Adopting this approach, Netflix, which we all know and use and spend most of our free time on, has 3/4 of its new orders that come from recommendation. So basically, almost all of the money that Netflix makes from buying from us staying on the platform and watching the new movies is from the recommendation system itself. Another very eerie and somewhat creepy example is the one for Target. Target has a system that is predicting a human's behavior, and actually is predicting if a customer may be pregnant, which is important because since there is a pregnancy, there is a watershed moment for couples when their shopping behavior actually is open to change. These women that were in the third month of pregnancy actually bought a lot of lotion at around unscented lotion around third month of pregnancy, and that a few weeks later they tended to purchase supplements like magnesium, zinc, calcium, and iron. There is a very interesting story about this recommendation system where an angry man actually stormed into the manager office in Target in Minnesota, and he demanded to speak with the manager. And he told the manager, he showed the manager the mail that his daughter got, which actually was a mail with coupons for cribs and baby clothes. And he actually asked the manager, "What are you trying to suggest, that my underage daughter gets pregnant?" And there was a lot of hustle around this. And the next day, when the manager called to apologize for this to the man, he actually got a very apologetic tone because after having a talk with his daughter, they found out that she was pregnant, and there was some activity in the house they did not approve of. It's actually very eerie and surprising to know to see the precision and accuracy to which big data can actually predict the behavior of our loved ones and the people around us better than us, actually. Another use case is in 1990s Walmart product placement. This is an example of how big data and machine learning help big companies make more money. And this is in the stores themselves, actually. Walmart noticed that during hurricane seasons, people bought a lot of flashlights, but they also at the same time bought Pop-Tarts. Now, Pop-Tart is a non-perishable sweet breakfast dessert. And when they noticed that before hurricane season, they would actually stock their stores with a lot of Pop-Tarts and put the Pop-Tarts at the front near the counters. And this helped them make bigger sales. Another example is from Experian, which is actually a customer of ours. Experian has developed a product that's called Income Insight. What does this product does is that it estimates people's income level partly on the basis of their credit history. That's using machine learning and big data in order to predict their credit debt. Basically, it's developed by analyzing the huge database of credit histories against the anonymous tax data from the US Internal Revenue System service, and to create a prediction regarding a person's spending ability. In order to do this through the forms themselves. If you don't use income insight, it would cost probably $10 a piece. So it would cost around $10 to know one person's credit history. But if you use predictions and machine learning and big data and experience income insight, the estimate cost for one person becomes less than $1. So this is one more example of how big data and machine learning has already been used in the past to increase the profit of the big companies and to reduce the cost of services. Now, for now, we have seen an example. We have seen a lot of examples that were connected with the big companies and making a lot of big bucks for the big companies. But now I would like to present you with the example for Watson and how big data helps save lives. In this example, just to give you context, premature babies are called preemies by the doctors in Canada, and IBM through Watson with the Institute of Technology, we're working with a number of hospitals in Canada on a software that would help doctors make better diagnostic decisions when caring for premature babies, preemies. The software captures and processes patient data in real time, tracking 16 different data streams, such as heart rate, respiration rate, temperature, blood pressure, and blood oxygen level, which together amount to whopping 1,260 data points per second. The system can detect subtle changes in the premise, a condition that may signal the onset of infection 24 hours before the overt symptoms appear. This means that just quote by the doctor itself that used the system, you can't see it with the naked eye, but the computer can, which is basically what the machine learning did. The advanced warnings also lets doctors treat the infections earlier with lighter medication interventions, or alerts them sooner if a treatment seems ineffective, which improves the patient's outcomes, which means that actually people's lives have been saved with the use of this technology. Another very interesting example is a Manhattan example from 2007, and is called Man versus Manhole. Now, for those of you that don't know, this is a manhole cover. And what was the problem? The problem was that due to the old installation and the already overloaded infrastructure, they had a problem where a lot of manholes actually, due to problems in electricity and gas pipelines, exploded, which could cause actually caught flames, which could cause property damage or even injure some civilians. And basically, the idea for this example is that every year a few hundred manholes in New York City would start to smolder as their innards catch fire. Sometimes the cast iron manhole covers, which weigh as much as 300 pounds, would explode into the air several stories high before coming crashing to the ground. And seeing this problem, it's a big data problem. It's a very complex problem. Just for to give you a rough estimate, 94,000 miles of underground. There are 94,000 miles of underground cables in New York City, and also there are 51,000 manholes and service boxes. So basically, out of those 51,000 manholes, you would have to predict which ones were the one that would explode in order to service them before they exploded. In a test on the Bronx grid, they analyzed all the data that they had up to 2008. Then they used the data to predict problems, to spot problem spots from 2009. And the top 10% of the manhole predictions actually contained a very big 44% of the manholes that ended up having severe incidents. So basically, they managed to predict 44% of the manholes that would explode. Now, there are a lot of other use cases, but these are some of the other big companies that are worth mentioning that use big data and machine learning. One of them is Yelp. We all know Yelp. It's actually reviews site that gives locals and tourists recommendations of restaurants, bars, saloons, and even dentists in their area, because we all know that we can have teeth problem when we're on a holiday. And with the use of machine learning, Yelp has a fine-tuned image curation to provide users with the most accurate photo captions and attributes in order to maximize the accuracy of the content that is provided. Another one is that is worth mentioning is Pinterest. Pinterest is a social media service that's a bit of target from the norm. It uses machine learning for the following services. It uses machine learning for spam moderation, content discovery, and even ad monetization that take place with machine learning in its center. We all know what Twitter is, and probably have seen the Twitter example with machine learning for the sentiment analysis. Just to give context to those that are not aware, Twitter is a social media service where users exchange information through concise, primarily text-based blobs. Twitter uses machine learning algorithm to score tweets based on various metrics. Another one that is important to mention is Baidu, which through a project called Deep Voice, they plan to engineer human speech with genuine human voices, which would actually change the automated recorded messages on the machines. And also Salesforce is worth mentioning since it's part of our lives. Salesforce gives business the tools to scale their marketing efforts, and it uses machine learning to actually give the best marketing propositions. Another one is Intel. Intel, as we all know, is chip manufacturer, which might sound vague because Intel is designing chips both for personal computers, laptops, but also for servers. At the moment, you are seeing this presentation on my laptop, which actually uses Intel chips. And also it's worth mentioning that they have their Nirvana chips are designed for data centers and utilize machine learning for major data processing. Nirvana chips are able to transfer up to 2.4 terabytes per second with very low latency, and machine learning is big key to this ability. Now, after this example, it is worth saying a few words on the future of machine learning and big data. As we've seen with the increase of data generated by ourselves, by the introduction of Internet of Things, and by the smartphones with our data, we're constantly increasing the number of data points that are created. Having this in mind, and having in mind that already the big giants are using machine learning, that means that the smaller companies will have either to step up to the plate and implement machine learning in their business models, or actually be exterminated by disadvantage, by this competitive edge from the big companies. So we've talked about what the big data and machine learning have done for the companies, but now let's say a few words about what it has done for ourselves as engineers. Most of you are aware for some of these positions, but mostly just to give point, machine learning and big data gave rise to the following professions that are part of the software engineering profession. One is data scientist, another one is data engineer, machine learning engineer, and also from the DevOps perspective, we have machine learning, ML ops, and data ops engineer. All of these are in charge with the development of algorithms, taking care of different life cycles in pre-prod and prod environment, both for the algorithms themselves, for the models trained, for the data curated, for the data processed, for the future processing of data. And just so that you don't get mad at me, data scientist doesn't come from engineer perspective, it comes from science or from statistics background. Just to give you some statistics that are for 2020, IBM predicted that 2.7 million of open jobs in data analysis, data science, and related careers will sprawl. And actually, this number has been surpassed by a whopping 4 million open jobs. 39% growth in employee demand was predicted again by IBM for demand for both data scientists and data engineers, which actually meant that 39% it was again surpassed. I think it was by 45%, 44 to 45% growth in employer demand. Also, another interesting perspective to see this is from HR perspective, is that data scientists and data analyst jobs remain open for 5 days longer than the average than all other job openings, which means that HR has a bigger difficulty to close these job openings due to the high demand and low supply of data engineers and data scientists. And the last one is that 59% of job in the future will be in finance, information technology, insurance, professional services, and careers. So basically, this means that all of the big companies that we are currently work on or will work on will use big data and machine learning to gain that competitive advantage.